are finishing what we started yesterday, which is on page 129 in your interactive notebook. If you'll remember yesterday, well, the first thing, or the only thing we accomplished on this page was numbers 1, 2, and 3. And what you know from yesterday, let's just remember on number 2. If you multiply straight across, you can, but then you have to do all the factoring out of common factors at the end, which can be complicated if you end up with big numbers. So it's a lot easier if you factor out those common factors here at the beginning, making sure each of your fractions is in simplest form, and then seeing if those two fractions have any factors in common. So we looked at this one in a few different ways yesterday, but let's just look at it this way right now, for those of you who were gone. 4/6, is 4/6 in simplest form? No. How would we simplify 4/6? What would we divide by? 2, because they both have a factor of 2. 4 divided by 2, 6 divided by 2. What about 15/25? Is there a common factor between those two numbers? What is it? 5. So 15 divided by 5, 25 divided by 5. Yeah, and so now we've got 2/3 times 3/5, and we've got a 3. That's a common factor. 3 divided by 3 is 1. 3 divided by 3 is 1. So we have 2/5. Now, what all did we factor out? What numbers did we factor out? Well, just tell me each number, each individual factor that we factored out. We started by factoring a 2 out, and over here we factored out a 5, and then here we factored out a, so we factored out a 2 times 5 times 3. We factored out 3 different things, didn't we? And see, if you had just done this straight across and you'd gotten 60 over 150, you'd have had to have simplified that, right? What's 2 times 5? 10 times 3? So you would have had to have divided those both by 30, but I guarantee you very few people would have caught 30 right at the beginning, would you? You'd have probably divided by 10 and then divided by 3. It's a whole heck of a lot easier if you can just get them right here at the beginning. And that's what we're going to be working on. The same rules apply when you have polynomials, okay? You all right? You all right? I think everybody is. I'm exhausted, so I hear you. I feel your pain. Get some. If that's a little better. Let's take a look at this A. Now that should be in your notebook, correct? Now we're multiplying those together. Now the first question I want to ask you is this. How many terms do you see right there? 1, because terms are separated by what kind of signs? Addition and subtraction. Yeah. And since we don't have addition or subtraction signs, that's just a single term. So how many, what's it called? What nomial is a single term called? Monomial. Good. So that's a monomial. What about that denominator? 1 term also. 1 term, 1 term. So I've got 2 fractions and all we've got is monomials. We're going to treat that, folks, just like we treated this. Just like it, okay? So what we're going to do is we're going to see, let me get some color. Will this fraction right here simplify any? How will it simplify? You bet. And in fact, do you mind if I write that bigger? Because it's real hard for me to work right there. Okay, so there's the 4. X cubed over x, you said is x squared over, right? There's no x left in the bottom. What about the y's? Good, I just have 1 y on the bottom. So what does that fraction simplify to? Good. So I'm going to have 4x squared over y for that fraction. Does anybody need extra support on that piece? Now let's look at that second fraction. All I can simplify is the y. Yeah, I believe you're right about that. So that's going to be 7x to the fourth, and in the bottom there's going to be a 4. What about the y's? Y cubed over y? Y squared where? Good. Now we're going to look between the two fractions at the numerator of one and the denominator of the other. Do we see anything between a numerator and a denominator that we could factor out? 4, yeah. Okay, I've got a y squared over y. How's that going to end up? A y on the top. Good. When I multiply like bases, what do I do to the exponents? You add them. 7, x to the 6th, y. I don't have over anything, do I? Just divided by 1? There you go. There you go. Questions? Now, I do believe what we're going to look at, this page is multiplication, the next page is division. We'll do most of them. I don't swear that we'll do every one, but we'll do most of them. What I'm looking at is half hour. We should be able to knock this out within half hour, okay? Let's look at B. Look at that first numerator. How many terms do you see? 2, so it's called a binomial. Good. Denominator is a binomial, trinomial, binomial. Yeah, just reviewing the words. Now, when you have binomials and trinomials, the first thing we're going to do, by golly, is we're going to factor. We're going to factor. What's wrong with this numerator, though? Not in standard form. So we're going to put that sucker in standard form first. How would we rewrite that in standard form? Good. So that's going to be negative 5x squared plus 20x over, let me just do it this way. So the first thing I'm doing here, and you may just want to write above this to save yourself space. Why don't I just do that too? So we don't have to rewrite the whole thing. What's your GCF in the numerator? It's 5, but I don't ever want you to leave your leading coefficient negative. So factor out a negative 5, okay? So we're going to have negative 5. Oh, but if you factor out a negative, what happens to all the signs? Good, they all change. So what am I left with if I factor a negative 5 out of this? X squared minus 4. Wait a minute. Oh, I didn't write that down right. Oh, okay. Yeah, I didn't write that down right. That negative 5 is not my GCF, is it? Negative 5x is my GCF. So negative 5x. Now let's do this cookie right, okay? What have we got? X minus 4. How can we factor that denominator? So we're right here. Good. X is your GCF. Times what? Now we're right here. Oh, that's a trinomial. Is there a GCF? No? How will that thing factor? Mm-hmm. Over? What's x squared minus 16? It's a difference of two squares. Yeah. X plus 4 times x minus 4. Now that everything's factored, what are we looking for? That's right. Any common factors between numerators and denominators? Either. I can look in this fraction here, I can look in this fraction here, and I can look in this numerator, this denominator, this numerator, this denominator. So wait, what now? Okay, what about the negative 5x over x? No. Let's, okay. There you go. Are you okay that x plus 4 factors out? You see anything else that factors out? X minus 4 factors out. X minus 1 factors out. Now you guys, some of you were saying the answer is negative 5x over x. But those x's will factor out. So what's your answer? That whole mess, I don't care what x value you put in there except for, what could x not equal? 0. 0. X cannot equal 0 because that would come from right there. 1. Negative 4. Or 4. There are my excluded values. Remember, what does an excluded value do to the problem? Why can I not use them? Good, because I get 0 in a denominator. And I can do that. Okay. Let's look at C. All right. Do you see any factoring that we can do? None in the top? Okay. So x plus 2 over what? Do you have a GCF in the bottom? Backwards. 3 times x plus 4 times good, because what's that denominator? Good, it's a difference of two squares. Now remember, we're looking for common factors within a single fraction or between the numerator and denominator of different fractions. The x plus 4s, the x plus 2s. What's my answer? 1, right, because 1's left in the denominator. 1's left in the numerator because anything divided by itself is, 1. Denominator is 3 times x minus 2. Do you have to distribute the 3? No, if you want to, go ahead, but you don't have to. Are there any x values that are not allowed here? Plus and minus 2 and negative 4. There you go. There you go. You doing okay? All right. D. What do you you see? What do you see in that left denominator? It's not a sum. It's a difference of 2 cubes. It's a difference of 2 cubes. I don't know if you remember back to Monday. I barely do. But we did factoring review. And I do believe that was one of the problems we did, or real similar to it. Soap. Remember soap? Yeah, same opposite, always positive. That numerator doesn't factor. What's the cube root of x cubed? X. What's the cube root of 8? 2. So that's going to be an x and a 2. We'll deal with the signs in a minute. What sits right here is this squared. This squared. What sits at the end is this squared. And what sits in the middle, remember, is this times this. And the signs, same, opposite, always positive. Same as that one, opposite of that one, and always positive. Let's remember that. Do you remember why that one is always positive? Remember where it came from? Squaring. If you square anything, it's always positive. That's why that last one's always positive. What's the denominator here? 1. So this is times x squared plus 2x plus 4 over 1. Do we have any common factors? So the answer is x minus 4 over x minus 2. But x cannot equal 2. Now I want you to think about something right here. X squared plus 2x plus 4. I just want your brain, okay? I don't want a pencil, I want your brain. Would that ever equal 0? Well, how could I solve that quadratic equation? I could factor. I could do the quadratic formula. I could complete the square. Oh my gosh. Oh my gosh. Will that factor? Well, you told me a minute ago it wouldn't factor. That won't factor. Can you come up with 2 numbers that'll multiply to give you 4 and add to give you 2? So it won't factor. It won't factor. So we could complete the square. Do you remember how to complete the square? Anybody remember how to do that? Let's do that just to review. Just to review. It's been a minute, hasn't it? To complete a square, we move the constant to the other side. Don't write this down. Let's just work through it. You subtract, get rid of the constant. How do I figure out what goes right here? What? Half it and then square it. Half of 2 is 1 and 1 squared is 1. So remember, if we put the correct number there, which we did, this one factors into something times itself. You remember that? You were good at this when we did it. I wanted to do this just to remind you what you were good at. Yeah, you're like, I don't remember that. Well, maybe we need to remember. Oh, good. Then I square root both sides. We can stop right there. Square root of -3 is an I, right? Here's what we know then. when we get an imaginary number here, that tells us that the only answers are imaginary, which means this never equals 0. So you could stop right there and say, nope, answers are imaginary, so this quadratic will never equal 0. It's exhausting. I hear you. I hear you. So 2 is the only excluded value. Let's skip E. Let's do F. Here's what I want to stop. Here's what I want you to do. I want you guys to factor that. You guys factor that. You guys factor that. And I'll factor this one. So we don't have to factor all 4. Okay? Oops. I need to go a little farther. Mine, I got the easy one. Okay, you guys, when'd you get here? Good. If that was not your assigned one, write it in. That's the answer to that piece. This group. X minus 5 times x plus 2. X minus 5 times x minus 8. Excellent. And there's mine. X plus 4 times x plus 3. Any common factors? X plus 3. And that appears to be it. So simplified, x plus 3 times over what can x not equal? 5. What number do you put in there for x to make that equal 0? So 5, negative 2, negative 4, negative 3. Can the numerator equal 0? Yes, numerator can equal 0, so that's okay. We're doing good, doing good. Do you remember when you learned back a long time ago how to divide fractions? Yeah. Had something to do with reciprocal, didn't it? A reciprocal. Multiply by the reciprocal. Good. Okay. Listen, all you got to remember about division is it's one step and then it's a multiplication and you do what we've just done. 1/2 divided by 3/4 is the same as 1/2 times 4/3. And then you do exactly what we've been doing. Do 1/2 times 4/3. I don't want 4/6. Do you see any common factors between the numerators and denominators? Yeah, you see a 2 goes into 2 and into 4. So see, one step to change it to a multiply, and then it's just stuff you already know how to do.
So do you always do the second fraction?
You always do the one that you are dividing by, which is the second one. Yes, always. What does this say? 1/5 divided by 4/5, which is the same as 1/5 times 5/4. There you go. 1/4. There you go. 1/4. Now let's look. What is 4 as a fraction? So 8/7 divided by 4 is the same as 8/7 times 1/4. Good. Good. The same rule applies to polynomials. You do the same daggum thing. Now, how many are there here? 6?
Yeah.
Let's look. We're for sure going to do 1. How about 3 of these, you reckon? Okay. Let's look at A, you reckon? A? Okay. If you start finding common factors right now, I'm going to come slap your hand because it's a division. You got to change it to multiplication first. So this is going to be 4x cubed over 9x squared y times 9y to the 5th over 16. Now it's the same problem you've been working. The 9's will factor out. How many of the y's? I got a y to the 5th here, and I got a y here. That's going to be a y to the 4th. Do I have any left in the bottom? Now I got an x cubed over x squared.
X on the top, nothing on the bottom. And that's going to also, that 4 and 16. You know, 1 and a 4.
4 over 16.
That's going to be y to the 4th over 4.
Oh, hang on, you lost something.
Oh,
X, y to the 4th over 4. If you make your paper look like your brain threw up on it, you might have a hard time finding things. So just be deliberately neat, if that's possible. Oh, you know what? The one that was on the previous page and this one, we didn't do excluded values. Well, I just want you to think about it. Do you notice that in the denominator we've got x's and y's, right? But we don't have x plus or minus anything. And we don't have y plus or minus anything. You're right, so they just can't equal 0. So x cannot equal 0 and y cannot equal 0. Okay, so let's pick what, you want to do B? Fine. All right, B. What I got to do first. Now, let me tell you something. We can save ourselves a step. We can do our factoring and change to a multiply at the same time. What? So, let's look. Can I factor 4x? No. Can I factor 5x minus 20? How? Now I'm going to do times, but what's going to be the numerator? The x squared minus 6x plus 8. How do you factor that? X minus 4 times x minus 2. Are you okay doing that in the same step? I figured most of you would be okay with that. And then the denominator is going to be this. What have I got?
X minus 4. Any other things? So it would be 4.
Good. And I have that x.
Wait, 4 over.
Right. 4x over 5x would simplify to 4/5. X cannot equal 4, 2, and 0. 4, 2, or 0. Can equal anything else. I'm thinking D. I'm thinking D. Yes. D. That's right. Ultimately, I'm going to change this to times 1 over 3x squared minus 2x. Factor. Is there a GCF in that mess right there? Nope. So how will that factor?
It's gonna be 3x times x.
I know it's going to be 3x and x. What are my signs? Different. Good. They're different. How do I factor 10? 2 and 5 or 10 and 1? Which one do we want to try first? Try 2 and 5 first. Now remember, I want you to try to think in your head. Try to like see.
Minus 3x minus 2x plus 5.
Okay, I've heard 3 people say a minus 2 goes here and a plus 5 goes here. Is that right? That'll give me 15x minus 2x is 13x. There you go. There you go.
Over 6x squared.
Times 1 over. Will that new denominator factor? How? There's a GCF of x. Good. X times. There you go. So the 3x minus 2 will factor out.
And then
1 over 6. No.
1 over the x.
X plus 5 over 6 squared.
Okay, don't you write this. Don't you write this. Will those factor out? No, because you just pulled apart a factor of x plus 5. What? Right, you can't factor out between 2 denominators.
Excuse me.
No, same reason. See, you can think about it like this. When you have things added or subtracted, they are married. Okay? That x and the 5 are married because they've got a plus or minus between them. You cannot cause a divorce. You oh. Sorry. Sorry. Now I feel bad. Now I feel bad.
I don't think that was a valid for like legitimate statements. That's just Say psych right now.
That x and that 5 are held together in a bond that you are not allowed to break.
There we go.
That plus and minus is a bond that you cannot break, okay? So what's the answer here? I feel terrible. What's the answer here? X plus 5 over 6x cubed. Is there anything that x is not allowed to equal? 0. Three x minus 2 cannot equal 0. I think we did one like this yesterday. I think. How do you solve that little equation right there?
Oh.
Add 2 and divide by 3, so x cannot equal 2/3. Yeah. Didn't we do one like that? Okay, I thought we did. I'm not going to do letter F. Which one of those? You multiply by the reciprocal of which one? The second one. Some of you are going to want to multiply by the reciprocal of the first one just because it's not a fraction. You leave it alone. You leave it alone. Now, that's right. You can absolutely just put a 1 under it and just remind you, don't touch it. Okay. You have learned how to simplify rational expressions, multiply them, and divide them. My goal was to be finished with that. What did I say? We finished in time.